Good afternoon, good evening. Due to the number of students I'm dealing with, I cannot teach only a single topic. It will take if I teach one child the whole topic, that will even take maybe 2 weeks. So the only thing I can do, if you have a question in a specific area, you can ask me on the comment section and then I explain to you. Tomorrow I'm going to explain about mole concept. Especially, mole concept is a concept that is synonymous with paper 3. At least there'll be a question on moles in paper 3 in this year. You can also get some questions in paper 1 or paper 2. In paper 1, utapata hizi maswali ya Gay-Lussac law, also gets question on molar gas volume. You can also get questions on Faraday's law. You need to apply the mole concept. Enthalpy, you must apply mole concept. So mainly mole concept is required in practical, that is chemistry paper 3. So I will have a sample of a question in chemistry paper 3 and we'll go through it together. The reason why I feel the most important thing is to do the practical is because what I'm sure you can go to paper 1 and 2 and you fail to find a single questions on moles. But paper 3, there will be questions on moles, which will be minimum of 15 marks to 20. So it is very important in paper 3. So I will develop a question, an example, and I'll show you how we go through it together so that you understand. For those people who have asked me to explain for them mole concept. On Sunday, I will also post a video explaining about what we call structure and bonding. Today, I just talked about why calcium has high melting point than magnesium, and calcium has a large atomic radius, simply because of how the structure of how the atoms are arranged in calcium structure makes the atoms be very close to the localess electrons, and how the atoms of magnesium are arranged in the structure make the atoms the nucleus of the atom to be far from the delocalized electrons, and the nearer the delocalized electron to the nucleus, the stronger the metallic bond. So I will talk about structure and bonding on Sundays. I'll post a video and we'll continue learning. And if you ask me for a specific concept, I'll explain in detail. Any definition, I'll explain with the illustration. I haven't seen anyone asking me about detergents, petroleum product, because KCSE since 2017, they are setting applied chemistry. And one of the things they told us that, I remember the chief examiner alisema wa theory paper that they are looking at Vision 2030, food production, climate change, and many others. So the questions that are tested in theory papers are applied. Require you to apply knowledge. And that's why I come in. That knowledge application is what I love. My concepts are related to reality. I bring chemistry to home. If I want to explain for you structure and bonding, I use this house is made of stones. The stones are the particles present in the metallic structure, we say atoms. And then between the stones, there are cement, which you call bond. So when the stones are held by very strong cement, it requires enormous energy to bring down the house. But kama mawe imeshikwa na udongo, it requires little energy to destroy the house. So when the bonds are strong, the energy required to break the bonds are nyingi. But when the bonds are weak, you require very little energy to overcome the bonds. So we shall talk about metallic bond. We shall talk about what is covalent bond. We shall compare covalent bond in van der Waals, what is dative bond, what is double covalent bond, what is double triple covalent bond, why is the structure of water V-shaped, the molecular structure emerging V-shaped, na carbon dioxide ni straight chain the molecule. So these are applications that I will go through on Sunday, and I hope you'll enjoy. Thank you for those people who have viewed. Continue subscribing and viewing. May God bless you. Enjoy the rest of your weekend. Thank you.